All right, quick reminders. You have your still the on-demand TA hours about the labs, especially for lab number 4, which I just released last night. Lab number 4 is more about inheritance. Also, we try to accumulate the kind of object-oriented basics and the more advanced interaction pattern that you kind of saw in the previous lab. We try to advance that even further in this lab. So I would say arguably, lab number 4 can be the one you really want to dedicate the most amount of time. And in the coming programming tests, that's going to happen this Friday. It's not going to cover lab number 4, but it will be covered in the final lab test in August. So definitely try to struggle with it, and then let me know if you got any trouble proceeding with the lab number 4. And for your programming test number 1, I released the result also earlier already. So if you got any concern, you can speak to me during the office hour. And also, if you really want regrading to be done, you can also submit a request, right? So all the procedures there. And for programming test number 2, that's going to happen on this Friday. The same kind of procedure and expectation. You can definitely refer to the guide for the coverage. We also gave you the practice test. Just pay attention to it. And then tomorrow, I'm still finalizing the details about a review session tomorrow, Wednesday, but most likely 4 p.m. But I will need to confirm a little bit later. I'm still waiting for some details. So please just bear with me. I'll reach out to you either a little bit later tonight or very early tomorrow morning. But hopefully you get enough time if you need to commute to the school for that. All right, your priority now should be catch up with the lecture since we already started talking about inheritance, which is a very, very challenging topic, but it's definitely something you should know for advanced OOP. All right. All right, any questions about the course? All right, so let's do a quick recap, and then we'll continue with the inheritance. As I said, it's going to be a very long journey for the inheritance, but I'll guide you through. Any time with any questions, just let me know. But today, it's still going to be very heavy, just not just yet. We still need to pave some foundation for you to understand inheritance. We'll get there. So last time, we basically finished the last bit of example about equals method. You can definitely refer to this particular exercise, especially for this one here, about figuring out which version of the equals method that's going to be called. Again, if you want to figure out which version of method is going to be called at the runtime, you always have to pay attention to dynamic type. It's also going to be some tip I'm also going to emphasize again and again and again. Keep that in mind. And we talk about person versus person collector. You can see this pattern over here also in your practice test. I think that's going to be very useful for your upcoming programming test as well on Friday, right? So take a look at that, especially figuring out exactly, again, which version of the equals method being called. Understanding that on the paper is going to help you when you actually design your own code. And then about the JUnit test cases, right? So I think, of course, in the case of programming tests, you don't really have to dive into that much detail about tracing. But for the written test and also for the exam, you also have to know, even for these two method call, for example, we are really calling the same version of the equals method. But the difference is which part of the equals method is going to give you the true return result, right? You also got to know exactly where. So that's one example we did last time. So please take a look at the other 3, right? So they should not be too bad for you to trace. And the diagrams I really drew over there also is like a template for you to really help you trace the code. Whenever you want to figure out exactly how things will behave at the runtime, drawing some diagram will be the best way to proceed, especially for your written test and exam. Okay. All right, so that's about the equals method. Any questions about the equals method? All good? Alrighty. And we move on to inheritance. So there will be 2 running problems that we're going to talk about when we talk about inheritance. This will be the first one. The other one, most likely, I will introduce maybe Thursday or maybe early next Tuesday, right? It's coming. But this one here is a very simple problem there that actually it's quite a small one, but it really illustrates many things that's interesting already. So we have a student management system that's going to collect the students. So somehow we can expect to see some kind of array or multiple arrays. That's something I'll elaborate a little bit more today. And also we got students. But the student, there are 2 kinds of students. Either resident students, in which case we have to worry about their premium rates for calculating their tuition. And also we got non-resident students, in which case we have to worry about their discount rate. You can see depending on which kind of student you're talking about, you may have to have certain applicable attributes or methods that's only for that kind of students. That's really give you some hints about you may want to use inheritance ultimately. But that's something we'll see. What if you don't really have inheritance? What kind of design principles are you going to suffer from, right? That's something we'll go a little bit deeper in the first half today, or first 1/3. And for there are also some common attributes and methods both kind of student will share. For example, each student has a name, they have registered courses, and also similar constraint on the maximum capacity for their courses, and also how do you calculate the base amount about the tuition, right? Things like that. So that's really about the example we're going to go over, right? Just a quick recap. And we're going to dive deeper into it today. And we talk about 2 design principles I think you guys should really know for at this level already, even though it's a 2nd year course. But later on, once you get to 3rd year software design course, you'll learn many more design principles. But let's learn about these 2. So one thing is about cohesion. Cohesion simply means you want to have each class containing only the attributes and methods that are somehow related to each other under a particular theme. You shouldn't really have 2 attributes or 2 methods that somehow not really related to each other for some common purpose. If that's the case, you have some violation of cohesion, which we kind of briefly described last time. I'll recap again. The second one here, the name itself may not make too much sense to you, but that will simply say you have duplicates. You got code repeating itself multiple places in your Java projects, in which case, if you really want to make a change to that particular fragment, you have to change multiple places, right? So that's not a very efficient way to really develop your software. Efficient not in the sense of runtime, efficient in the sense that you have to go to multiple places to make a change. It's not as maintainable for your code, right? That's something you will have to appreciate once you get a little bit more coding experience later. Now we're going to talk about these 2. Okay. The first design without inheritance for implementing the student management system goes like this. So each student, we only got a single student class. And then you can see here, we violate this cohesion principle right away because we try to put 2 attributes over here that somehow they are not really related to each other. So premium rate is only applicable to resident students, and discount rate is only applicable to non-resident students. So if you're putting 2 things that are not related to each other in the single class, it violates cohesion. Just one more time. Over here, for example, let's say I create a resident student right here, and I pass the kind number 1, right? If you're curious about exactly how this works, you can refer to the recording from last Thursday, which we explained in detail. Okay? Let's say I'm creating RS, and with the kind code being 1. That means at the runtime, RS is only going to have the only going to have the premium rate that makes sense. As on the other hand, for the discount rate, it's simply going to be wasted for its space. It's never going to be applicable for resident students, right? So in that way, you really see the worst case really for cohesion. You really don't want to have anything like multiple attributes or multiple methods. They really don't really share the same purpose, right? So that's a violation. And you will also see that you can see for every method, we also have to distinguish between is the current context object, RS, NRS, is it really referring to some resident students or non-resident student? That's why we got the same kind of if and else structure here. Kind equals 1, kind equals 2. So this kind of structure will duplicate itself for almost every method. So whenever you got duplicates, that's a very good sign to you. You're violating another design principle, single choice principle, right? That's basically where we were at last time, right? Cohesion, easy to tell because these 2 attributes are not really related to each other, right? Some of them might be applicable sometimes, some of them may not be applicable sometimes, right? As I described. That's about cohesion. And for single choice principle, okay, that's the last part that we talked about last time. Let me make a little bit more annotation just before we end this discussion here. So what I said last time was, for every method, you have to repeat this kind of a check about whether the kind is equal to 1 or the kind is equal to 2. So now let's think about, if I want to make a change to my code, let's take one example. Okay, I'll take one of them just to show to you. The other one, you can try to think about it yourself as exercise. Let's say we want to introduce a new kind of students, let's say. All right, so that's a change I want to make to my Java code. And then let's say it's called international students. So we got resident, we got non-resident, also we got international. So that would mean I got another kind called international. I already got the kind over here, 1 and 2, right? 1 for residents, and also 2 for non-residents. And now I want to have another one, 3. That's going to be for international students, okay? So this one here is going to be kind is equal to 3. So let's now imagine how many places do I need to change just given this particular code fragment, right? So every time you want to really see what kind of student it is you're currently calling the method on, you have to tell what kind of student it is by looking at the kind attributes. That one should be quite easy to see because you can see get tuition and also register. Given that kind can be equal to 1 or 2 and also 1 or 2, now we also got a third possibility. It can be 3, right? So what do I expect to do? Do I only have a single place to change things? Not really. More precisely. So here I gotta add else if. First of all, for the get tuition, I would say this kind is equal to 3. That means it is international student. I might need to do something specific to international students. Maybe this is different rate I need to apply. Similarly, there's a second place I need to change. So now it's more than one place. It's more than minimum. I need to add another branch over here. I might say, oh, sorry, not here. I might need to add just another branch. I might need to say else if. I'm repeating basically, right? This kind equals 3. In that case, I also got to do something for registration specific to international students. You can see in order to add a new kind of students, I have to change one place and also another place. It's definitely not single. So I'm violating single choice principle. Right? Exercise for you, you can think about what if I want to maybe make one existing kind obsolete? Let's say we no longer have like a resident students. How many places do I need to change? Right? Think about this question here. The answer should be very similar. You still have to modify multiple places, but I got to know exactly where are the multiple places I'm going to modify the code. All right, let's now recap about this design number 1. By using a single attribute over here for kind, for encoding the kind of students, we violated 2 design principles. We violated single choice principle, we violated number 1, cohesion principle, and also we violated single choice principle, right? That's a design number 1. Another thing I can also mention, normally when you actually violated the cohesion principle, right? We say that you're putting too many things, too many unrelated things in a single class so that your class gets too big. So we would say you really get into making your class a so-called Superman class. Okay? Unrelated attributes or methods that's going to make your class a Superman class. And Superman class has a negative connotation, right? It doesn't really mean it's good. It's actually bad. Superman class simply means you have a single class that actually got too many things to do. That's not the way to go for software design. You want to make sure the single class only does a single thing and do it well. All right? That's about cohesion. So Superman class, you want to avoid. In the context of OOP, you want to distribute different functionality into different classes as much as possible. That will be the way to go. Exactly what the balance should be. As you get more coding and design experience in the upper year, you also appreciate that a little bit more. But at least keep in mind from this course, there's such a thing. All right, any question about this one here? All right, let's now move on to another design attempt, the second one. That one there also does not use any inheritance. I'm going to look at that, and let's do design exercise once more to see which design principle, again, cohesion and single choice principle, which one is going to satisfy and which one is going to violate. Okay? For the second design, I can show you a little bit on the slides. Also, you will see some code. And the code example for this second design attempt is also on the lecture side. You can also play with it and see how it goes. Okay, no inheritance. In this case, we actually got two classes. Rather than a single class called students, we actually got two classes, resident students and non-resident student, these two classes. Let's take a quick look, and then we can criticize on that. As I present fragment by fragment for the class, think to yourself, does it satisfy cohesion, and does it satisfy single choice principle? Resident students, okay? Resident student here. And then we got name, we got courses, and we got number of courses, right? Very familiar pattern. And also we got premium rates, which we know is only applicable to resident students. And in this case, we choose not to include the discount rate under the resident student class, all right? So you don't see that. And we got the constructor over here for resident students, and also we got the register method. Okay, the register method, which we know how each kind of student is registered into a course, it would be just the same way. You should add a course to the end of the array. And then we got get tuition. And the get tuition here, so this part here, just add up the fees for all the enrolled courses. That'll be the base amount. And then for resident students, since we know only premium rate is applicable, so we're gonna calculate using the premium rate. All right, that's resident students. Pretty straightforward, all right? Now, think to yourself, by following a very similar pattern, maybe, how are we gonna define another class to define non-resident students, right? For example, what kind of attributes should we declare? Here we got premium rates. I presume we need discount rate, right, for non-resident students and other things as well. And also think to yourself, if we are going to somehow define another non-resident student class, how much repetition of code are we going to have? If we got repetition, you kind of know which design principle you will also violate, right? Let's take a quick look. So the second class we have is called non-resident students, right? And then here we got name, courses, and NOC. So these are important because because we know every student, non-resident, resident or not, they got name and courses. And here we got discount rate. This is good because discount rate is only applicable to non-resident student, but not the other kind. So this is good. And then we somehow have to repeat the code for constructor. And we have to repeat completely the code for register. And also we have to repeat completely the calculation for the base amount. And then only in the last stage, we have to apply the discount rate, right? So now you can see lots of duplication right here, all right? Any questions so far about this second design, right? Straightforward, right? Based on this, before I switch the iPad for some quick discussion. Now, cohesion, single choice principle. Tell me which one is being satisfied, or which ones? Or can tell me which one's violated equally. Say it again. Okay. So you said cohesion principle is satisfied. Why?
Because there is no attribute or function which are not there.
Okay. For example, in the non-resident student class, we only include discount rate. We did not include premium rates, like in the first design. Cohesion, I agree. How about single choice principle? Why did you say it's violated?
Because we have a lot of code, like let's say public void register method, right? We have same method in the other class, so we can actually use that.
Yeah, that's exactly right. So between the two classes, you may have noticed that I kind of highlighted for you guys, right? When you go over the slides on your screen, you will see that the only parts that are kind of different between the two classes are highlighted in yellow. Everything else are duplicated. All right, so we got lots of duplication in this particular design. So before I just summarize what your fellow students said, which is completely correct, design number one that we spoke about last time violated both principles. This here makes some improvement by satisfying cohesion, but it's still violating single choice principle. So what we really want is to satisfy both design principles. What will be the way to go? Inheritance. All right, so hopefully you will see the kind of roadmap, right? It's really important for you to see not only the ultimate solution, but also how we evolve some imperfect solution. All right, let me now give you guys a very quick summary, okay, very quick. Okay? And then I'll highlight some important stuff for you to really pay attention to. Okay? So we got resident students, and also we got non-resident students. One thing I want to point out right away. So these two classes are completely separate classes. They are different classes, also they are different types. Okay? Let me write it down. So resident student here, and also non-resident student over here. So point number one, I want you to note right away, over here. So they are separate, independent, separate, unrelated classes. Separate, unrelated classes. You know, a little bit like a point V1 and point V2, right? Even though we kind of discussed them side by side, but they're not really related somehow, right? They're just different classes, okay? Resident student, non-resident student, they are not really related in any way, okay? And then the fact that we actually got premium rate here only, and also we got discount rates only here. So that tells us we satisfy cohesion, right? Let's highlight that. Okay, here and here. That tells us we got cohesion. Cohesion is good, all right? It's satisfied. On the other hand, we got lots of duplicates. Just for one example, if you look at the register method here, let's give you two examples. Register method here, and also most of the part about calculating tuition, especially for the base amount over here. Oh, let me just highlight a bit better. So just this part, before we apply the premium rates. And also you can see the register method here is also completely identical right here, almost like a copy and paste. And also you got this part, calculating the base amount, is also completely the same, right? So this duplicate tells you that it violates the single choice principle. 1, 2, 3, and 4. So single choice principle. So single choice principle is not being satisfied, right? Just a little bit more visual. And there will be something you guys can definitely do. I'll leave that to you. So this part here, simply just want you to trace very quickly. You create two courses, let's say 2030 and 3311, okay? And then you just create Jim and also Jeremy. So they are simply resident students and also non-resident student, right? Different kinds. And then we simply set a premium rate to be 1.25 and set a discount rate. So basically, Jim and Jeremy, at a runtime, the premium rate is going to be 1.25. And the discount rate is going to be 0.75. So now, these two students, they actually share the same courses. You will see that at a runtime, Jim is going to take this course and also this course. Jeremy also takes the same two courses. So when you actually calculate their tuition, think about what's going to happen. What they share in common is you're going to add up the fees for these two courses. However, in the case of Jim, you're going to multiply the fee by 1.25. In the case of Jeremy, you're going to multiply the fee by 0.75, right? So that's a very straightforward way to show you, about the different kinds of student we're dealing with, okay? So I will encourage you guys to really trace this one because that's rather straightforward, so we don't need to spend time on this. So I want you to specifically pay attention to Jim.get tuition and also Jeremy.get tuition, all right? One thing I will highlight for you. Think about which version of the get tuition is being called, right? Because here, Jim is dynamically pointing to some resident student objects. So it's going to call the get tuition from the resident students, right? So what you really want to pay attention to is for Jim, it has the dynamic type, resident students. On the other hand, for Jeremy, it has the dynamic type, non-resident student. How do I tell? You basically just look at here, the title of the box, right? And non-resident students. Once you see they have different dynamic types, you know that different version of the get tuition is being called. One is going to call this one here using premium rates. The other one is going to call this version here with discount rate. So that's something you want to pay attention to too, okay? So that's the second design without the inheritance. Okay. Any questions? Okay. Let me see if there's another one I want to show to you guys. Okay. Let me just talk about one thing as well. Okay. If you look at the slides, over here, we base non-resident student. We just spoke about it. Okay. Over here. And that's the test case I just went over with you. So please trace it and make sure you can you know exactly what's going on at the runtime. Okay. So one thing I want to talk about, just about single choice principle very quickly, right? So here, the problem is about duplicates of code, which violate single choice principle, we said, right? So here, just a definition about single choice principle, right? That's something we said last time. But how exactly it is bad to really violate single choice principle? I kind of gave you two scenarios in the slides. I'll go over one of them with you, pretty straightforward. The other one you can do as exercise. Okay, let's take a look at this one here. Let's say we got this and we got duplicates. Specifically, we got duplicates for the register method. You can see the register method here in one place. This is just identical register implementation in another place. We got two places, okay? And now let's say we want to change the registration policy globally for all kinds of students. So let's say somehow we want to say if the number of courses you have registered has exceeded, you know, some maximum allowance, there should be some exception, right? Which is not currently in place. So now the question is, this new policy should be imposed on only a single place in our Java classes or multiple places? Multiple, right? Because you have to somehow put this guy here. Right? Think about this is the new additional code you have to write, right? Let's say, where should you put it? You got to put it here. Also, you got to put it here. Multiple places. It's not a minimum. However, if you use inheritance, you will realize that, you'll see that you only need to change one single place. Okay? That's really something I want you guys to really keep in mind. May not be so easy for you to grasp. It's kind of like a more advanced concept. I think you guys can know. But you guys should deserve to know about this design principle. Whenever you got duplicates in your Java projects, you got to watch out for when you want to make changes. You got to go to multiple places to make changes, which can be more error prone and more inconvenient. Right? Another example would be, what if we want to somehow modify the get tuition formula? Right? Because currently, the base amount and the base amount over here are calculated the same way. But let's say we want to maybe also take into account inflation, right? In that case, you also got to change one place and another place. Again, single choice principle being violated. All right? So this one here, you can try to do a little bit yourself on the paper, you know, just to let yourself really visualize what's happening there. Okay? All right, any questions? One more thing before we move on to the real inheritance. All right, so we got the two scenarios, and now, so guys, you want to make a note yourself. Slide number 11. All right. So later on, when we go much further into the inheritance, I'm going to refer back to this slide again. So when we want to implement the student management system, think about this: resident students and non-resident students, they are unrelated classes. But how can we store a single array that's going to accommodate both kinds of students? You might be thinking maybe object array, but that's not the way to go. That's another story. You should never really have an array that simply store objects. It's going to give you lots of trouble, but I wouldn't get there. Okay. So the best strategy you can do is you have two separate arrays. One array of resident students, another array of non-resident students. Basically, how many kinds of students you might have in your system, you need to have that many number of arrays. Let me show it to you, okay? And the reason that I really want you to really pay attention to this particular slides is later on, we're going to have something called polymorphic array with inheritance. In that case, it doesn't really matter how many kinds of a student you have in your system, you only need to have a single array, and everything will still work. Okay? That's something I'll remark again once we get there. But that one is going to take us maybe another 3 or 4 lectures more. Okay? And then for this one here, we just want to see how we can implement student management system without the inheritance, right? Let me highlight to you the essence of that. Okay, so let's take a look. First of all, you can see we got a class called student management system right here, all right? And then, as we said earlier, the resident students over here and also the non-resident students, they are completely unrelated. Let me just remind you once more, okay? Because that's a really critical point. So these two classes are unrelated. Unrelated. So that's why we need to have all the resident students stored in one array, all the non-resident students stored in another array. We cannot get away from that. So now imagine this. What if we also got international students? A third array storing international students' objects. What if we got another fourth kind of student? You got to introduce another array, and so on. Right? So this non-inheritance solution in general is not really the way to go, because realistically, maybe beyond student management system, you might have 50 kinds of objects you want to deal with. In that case, are you going to have 50 different arrays? No, I don't think so. Right? And you can see we have some mutator just to add resident students. We got to do them separately, right? So this one here is going to add, is going to modify this array. And this mutator here is going to modify this array separately, right? And let's say we have a method here called register all. Okay? Let's say there's a common course that all kinds of students must take. I don't know, maybe in the first year, possibly the engineering ethics or whatever course, that every engineering student should take, and there's a common course, right? A single loop is not going to work because we somehow have to go over every array because they might be of different value for the counter, right? There are only 100 students over here, about 50 students here, so we're going to deal with them separately. So the first loop is going to deal with non-resident students. And also the second loop is going to deal with non-resident students separately, right? So that's why we're going to deal with this and also deal with that separately. Okay? Let me make a final remark. In the non-inheritance solution, that tells us the number of kinds of students tells you that the numbers of arrays you will need to declare. 1 and 2 in this case, but could be more. And also, the number of loops you will need to write to deal with them separately. For example, one loop over here and one loop over here, right? And if you try to visualize them, it's going to look like this. So we got this array over here, and also we got this separate array over here. So you can see each element here, one got resident students objects, the other one got non-resident student object, completely separate. They have nothing to do with each other. Once we introduce inheritance, we're somehow going to draw resident student and also non-resident student into connection somehow. That's going to be very beneficial for us. But it comes at a cost. Once you introduce inheritance, you're kind of subject to many rules that you have to understand how. That's why we're going to have that intensive discussion very soon. All right, so this will be the last page about non-inheritance solution. Guys, any question? All right, good. How about this? Why don't I show you very quickly just about the inheritance solution itself. It doesn't take much time to really go over that, and then I'll make some annotation, and then we'll take a short break. And after the break, we're going to talk about something a little bit trickier. Okay, we'll get there. Okay, let's do this. Let's take about 5 minutes. We'll see how far we can go. Okay, again, please make a note about slide number 11. Okay, when you study for the exam specifically later, you want to contrast slide number 11. Oh, by the way, you can see that right away if you want to. You can see that there is a link over here called a polymorphic collection of students. That is when we actually got inheritance. If you click on that, it's going to bring you to slide number 83, way later. And this slide here shows to you the improved version using a single loop and single array with inheritance, right? That's something you can Make sure you contrast and compare when you do your study for the exam. But let me just go back. You can click on the link again, you go back. All right? I'll let you play with it. Slide number 12 is just about visibility using like a private, public, and also something called protected. I will skip this just for today. I'm going to start with it. It's rather straightforward. I'll do that maybe in the beginning of Thursday. But for today, I want to do something a little bit more interesting with you. Okay? So let me just skip them just for now. All right? I'll promise I'll come back here on Thursday. Okay? So what I want you to talk about is very quickly about the keywords you should know. And that'll be very beneficial for your lab number 4 as well, which we just released yesterday. Okay? I'll go over all these in the beginning of Thursday, so don't worry. All right, inheritance. Okay? The student management system example is a rather simple use case for inheritance, which is okay, but on Thursday or next week, we're going to show you multi-layer inheritance, which is more realistic. But for today, let's focus on something simple. What we want to have is now solution number 3, which uses inheritance. And this solution here, which we'll see, is going to satisfy cohesion and also single choice principle, both of them. We're going to see exactly how. What's going to happen is we still have one class called resident students. And we have another class called non-resident students. So far, you might be thinking it's very similar to solution number 2 that we just talked about. Here's the difference. We are somehow going to relate these two classes by declaring something called a common superclass or common parent class. We're going to introduce another class here called students. And then to really make sure these 3 classes somehow related to each other in the way we intend, you're going to say resident students extends and non-resident students extend as well. So extends is the first keyword you have to know for inheritance. All right? So let's now go over the code together. Okay? And if you look at the following slides, you will see this will be the code for students. The next one will be the code for resident students. And the next slide will be the code for non-resident student, right? That's on the slides. But I'm just going to put them all together on a single page. We'll go over them. Okay? And then I'm going to signal to you about which part you should really watch out for. Okay, let's take a look at it. All right. Okay, we got students, we got resident students, we got non-resident students. And the reason that I draw arrow over here is because I got the keyword extends and also extends. Okay? So first of all, you want to realize extends over here and also extends over here. Whenever you got extends, remember this kind of sequence. Okay? So when you got the extends keyword, to its left will be the what we call child class or subclass. On the other hand, to its right will be the super or parent class. So the order really matters. Don't really mess around with your order because later on, I'm going to show you some example where you may be given a series of extends decoration from which you got to figure out exactly what's going to be the hierarchy, right? So in this case, you can think about resident students is the subclass, extends the student class, which is the superclass. Similarly, the non-resident student class, again, is a subclass, extends the student class, which is superclass, right? You can see students and student over here. That tells you student is a common superclass of these two. Okay? So you can think about the students and also the student here. So that one tells you this student class is really the common. Okay, let me just draw a little bit better. So this is the common super or parent class of the two. Of this one here and this one here. They share the same parents. Okay, that's number one. And what's the consequence of having extends? That simply tells you everything that's not private in the parent class will be inherited to the subclass. And this might sound a little bit familiar to you, right? We actually spoke about this somehow earlier. Remember the object class? we said the equals method is inherited to every class because every class is a subclass of the object class. Now we're having a similar pattern here, except that students, resident students, and non-resident, all the classes are defined by ourselves. So this will be the general pattern you want to remember. The parent class has everything, attributes, method that's now private, inherited verbatim into their child class. All right, already done. And then who's non-private? Attributes and methods are inherited to each of its child classes. So sometimes I might say child class, sometimes I might say subclass, but they really mean the same thing. So I might just use the term interchangeably. Okay? You can say a superclass, you can say a parent class, that's also fine. Right? So principle number one, remember, everything that's now private from the parent class is going to be inherited to the child class. All right? So that means over here, the attributes right here, and also the register method over here, and also you can see the get tuition method, the version that we define in the parent class is only going to calculate the base amount, just add up the fees for the courses without worrying about whether we should apply premium rates or discount rate. At this level, we don't really consider that. All right? Even this one here, okay, let me not go that far. This one has a different treatment. Think about the attribute here, and the method here, and the method here, they will all be inherited. So all these will be inherited. Inherited so that they can be simply reused without having to be redefined again. Inherited, that means they're reusable right away. To all subclasses. Two, I can say in this case, it's going to be resident students and also non-resident students. So that means we resolve the duplicate issue, meaning that this inheritance solution here will satisfy the single choice principle, right? We can draw that conclusion right away. So that means the single choice principle is satisfied. I'll talk about cohesion in a moment. All right? And then let's now look at the individual. So thinking this way, if you want to design your inheritance classes, the parent class should really store everything that's going to be in common among the subclasses. Anything that's going to be specific to the subclasses, define the subclasses already done. It's more like a very, some design principle you want to think about. Okay? So when you try to program, when programming with inheritance, let me make it a little bit more symbolic, but you will see the point. Okay? Let's say this is some parent class P. Underneath it, we actually got different subclasses. We may have child class number 1, we may have child class number 2, and we may have all the way to maybe child class N. We got N different child classes, right? As many as you like. So the principle goes like this. P over here should really declare attributes and methods common to all subclasses. C1, C2, all the way to Cn. Principle number 1. And this is going to make sure we satisfy the single choice principle. Single choice principle. Number 2. For individual child classes, You're going to inherit everything from your parent, yes. But there might be certain feature that only you possess it. For example, for resident students, I have premium rate that only belongs to me. If I'm in non-resident student class, only discount rate should belong to me, right? So the second principle goes like this. C1 over here, declare additional attributes and methods applicable to, let me write a little bit better, applicable to this subclass only. So in C1, in addition to everything that's inherited from P, we also declare some additional methods and attributes that's only applicable to C1. And similarly, for C2, we inherit everything from P. We also declare additional stuff that's applicable to C2 only, nothing to do with C1, all right, etc. And this one here, make sure we satisfy cohesion, because we don't really put anything that's unrelated to each other in the same class, right? So this is number 2, and that one is going to make sure cohesion is satisfied, right? So nicely, inheritance can solve 2 design principles at one go, but you want to know exactly how for each one of them, okay? Let's now go back to the student's inheritance hierarchy. Let's take a look at one more time, okay? So you can see that over here, we got under resident student class, we actually got here, so let me show you premium rates right here. And also we got discount rate right here, right? Premium rate is only declared as an additional attribute under resident students. And discount rate is only declared as an additional attribute under non-resident students, right? That's cohesion. Okay, this one here and this one here. Cohesion. All right. There are still a few more things I would like to talk about, but I would suggest we take a very short break by taking attendance. After the break, I will finish this illustration, and then we'll do something interesting. All right. Okay, let me pause the recording, and we'll take attendance. All right, so we are still looking at this code structure over here with inheritance over here. Okay, let me talk about a few more things. Okay. Number 1, let's look at the get tuition method. Okay. You can see in the parent class called students, we got get tuition. In the resident student class, which is a subclass, we got get tuition. In the second subclass, non-resident students, we also got get tuition. It seems like we got 3 different versions. Actually, that's quite true. However, the way we refer to these 2 versions, you got to be careful. We call them the overridden version of the get tuition method. And we also have seen this term before, right? We talk about overridden version of the equals method, a similar idea, all right? Let's not talk about that. So get tuition here, okay? So this is the parent version. This is the parent version inherited to resident students and also non-resident student, which means if the get tuition was not redeclared over here and the get tuition was not redeclared over here, the get tuition will just be here and the get tuition will just be here, like a default equals method from the object class, similar idea. However, because the resident student will somehow have to apply the premium rates and also non-resident student we want to apply the discount rate, we cannot just use the default version verbatim. We can reuse it, but we cannot totally just adapt it verbatim. Okay, so what's happening here is, let's look at that. First of all, you can see get tuition over here. We are redeclaring it and get tuition over here, right? So we call it the overridden version, okay? So this will be, let's say, star and also star star, okay, all right here. So star here is the overridden version of the get tuition in resident students, right? You can think about that one is more like a version number 2, right? The default version like a version number 1. And then for star over here, similar idea, okay? Star is also overridden. So overridden version of the get tuition method, but now it's in non-resident student class, so we can say that it's version number 3, right? So now, which version specifically, are we gonna call get tuition from here, or are we gonna get tuition from here? It depends on the dynamic type for the objects, which we'll get to very soon, all right? And let's dive a little bit deeper into this. You can see get tuition here. You will see there are 2 lines over here. First of all, we have, okay, I'll make it bigger for you, okay? We declare a variable called base amount, which will add up the fees for the courses. And then we simply say super.getTuition, all right? So that's the second keyword you have to learn. We just learned about extends, and also going to learn about super. Super, in this case, simply tells me that I'm going to get the get tuition from the super class. So can you think about super over here simply tells you that go to the parent class, which is students. So more precisely, in order for me to calculate the get tuition for resident students, there are 2 phases. Phase number 1, I'm going to get to my get tuition method in the student class and apply that verbatim, which is going to give me the base amount. I will store that into the base. And then the base over here is going to apply the premium rates that's only declared in this particular subclass. In a very similar way, how do I override the get tuition in the non-resident student class? Phase number 1, I'm going to calculate the base amount by using super. So I will go to the same parent class and use the get tuition again for the second time. So I didn't have any duplicate to be written in the subclasses, right? Go to that method there, get the get tuition for the base amount, and then apply the discount rate over here, right? So you really want to think about this one here and also this one here. These are really about reusing the same fragment of code that's inherited from the parent class without duplicates in the individual subclasses, okay? So these are just, okay? So you think about here and also here, okay? Reusing the get tuition from students. So you can see they got common phase number 1. But for the phase number 2, how we calculate for resident students will be different from how we calculate for non-resident student, right? You can see that. This will be the kind of thing you have to watch out for lab number 4, okay? You want to think about for individual subclasses, what will be the difference I have to make the method calculating things differently. Okay, that's the first super keyword. Another one you can see, which is also super keyword, but it's a specialized usage only for constructor. Okay, you can see for resident student class over here, you can see I don't say super dot anymore. Whenever you're using a super keyword, but you're using super as if it's like a method name. This one tells you that go to the parent class still, but look for the constructor that's going to take a string name. In which case, it's going to go to the student constructor over here. So we can just reuse these 2 lines of code to initialize the array and also the counter, right? Something like that, okay? So I want to show to you so you can see this one here and also this one here, right? The super keyword. You can see this nose here we got super dot, but here we got super parenthesis, right? It's different syntax. When you say super dot, that means you want to go to the parent class and call some method from the parent class. But when you got super parenthesis, that means you're calling the constructor from the parent class. Okay? But the purpose is really the same. We can reuse the code. So here, okay, this one here and also this one here. So we just go, reuse. reuse the constructor from students, which is right here. Reusing it. So we don't really have to repeat the 2 lines in each of the subclasses, right? So it's a very nice way, a very simple example, but very nice way to show to you at a introductory level the keywords you should know, right? So I think once you got super understood, once you got extens understood, you will be kind of ready for your lab number 4, right? Except I want to do 1 more or 2 more exercises with you. All right, study this code a bit, and then on Thursday I can do a little bit more recap, so we can study that again. Okay. So now let me now go to some exercise together with you. I'm gonna skip some stuff just for now, but I'll make sure I go back on Thursday. Okay. This is a very critical exercise that we're gonna make sure we understand, right? Because I can tell you that arguably this is the most important page for the whole inheritance lecture. Because all the theories, all the rules we're going to talk about related to inheritance is related to the concept I'm going to talk about, right? So I'll make sure this one here is understood properly, okay? And let's just revisit quickly. We got our student class, we got 2 subclasses right here. For the student class, we got name, courses, number of courses. Also, we got the constructor, we got register, we got get tuition. 1 version here, default version, calculating the base amount. In the resident student class, we got constructor, we got cohesion, premium rates, versus we got discount rate. And also we got get tuition that's overridden using the premium rates. And this one, get tuition, is overridden using the discount rate, right? So that's the structure, okay? Now, let's revisit idea about static type. Right? Remember that example page I said that will be something you have to know just at that point. Let's now make it very general. Whenever you are given some inheritance hierarchy like this, you got students, you got resident student, you got non-resident student. You got some inheritance hierarchy. And now whenever you're trying to declare a variable using one of the classes over there, as soon as you declare the variable with a particular type, that type is called static type, right? Let's now get that recall very quickly. So think about the declare type, student here, resident student over here, and also non-resident student over here. So these are called the static type. This one here, and also this one here. They are called a static type. And if you recall, we said that for static type, you got to remember it's going to define the range of applicable attributes and methods you can call. Right? That definition is still applies. But now I want to make it a little bit more intuitive for you. Thinking this way. S, RS, and NRS, they are declared using different classes. That simply means we got different static type. Okay? So think about this. For S, we know that the static type is simply students. For RS, we know that the static type is resident students. For NRS, we know that the static type is non-resident students. Right? They got different static type because they got different declared types. As soon as you know about the static type for a particular reference variable, you will know the expectation on that particular variable. So expectation is really the key word you want to somehow understand here. Okay? So that's why I highlight the expectation over here. Right? Expectation simply means, okay, I'll write it down. So the expectation of a reference variable, specifically given some inheritance hierarchy. And for our example here, inheritance hierarchy got students, resident student, and non-resident student. Okay, and then given expectation of a reference variable determines the range of attributes and also methods that can be invoked or called on that variable. It's basically just repeating what we kind of said back in the equals lecture, but I think just brush out our mind, okay? And how do we know the expectation? You want to look at the static type. And let's now try to do this exercise over here to be very systematic and thorough. So here, think about we got the context object being S or RS or NRS. And we're only talking about compilation. So whenever you kind of talk about expectation, that means you're trying to make some decision making related to compilation time. So it's only about compile time or compilation. So at this point, we only talk about whether or not a piece of code is going to compile. Okay? So given S, RS, or NRS being the context objects, we want to see what can really occur after the dot. If I put something here for after the dot, is it going to compile? It's something we're going to judge. All right? So here, I just give you all the possibility. You can see the name, okay, I'll just use acronym. Name, register courses, and also number of courses, and also register method right here, and also get tuition right here, right? And also got premium rates, which is only here, and also we got discount rate, which is only here, right, etc. Right? We got all the attributes and method that we may call on the variable, but we want to see which one is going to compile. For example, if I say s.name, if I say s.discount rate, which one is going to compile? Okay? 1, 2, 3. Okay, let's now start with S over here. Okay? Let's go one by one. S.name, would it compile? Yes, because name is exactly here in the same class. S.register courses, right? It's declared exactly here. S.number of courses also should be there. S.register over here, right? And also S.get tuition is also here. Okay? S.premium rates. Is it going to compile? It's not going to compile because S has a static type students. And student class does not declare premium rates. Premium rates only declared in a different class that's right here. Right? You can see the premium rate right here. Similarly, if you say S.set premium rates, also it's not going to compile. If you say S.discount rate, which only is declared right here, is also not going to compile. Right? So the way to see that is like this. So name, register courses all the way to here. They will all compile. S.name, S.register courses all the way to here, they will compile. On the other hand, these will not compile. The reason, let's now do a little bit further annotation here. You can think about all these. Are the expectation. Oh, you know what? Let me put it here. Let me make it a bit thicker. The name, register courses, etc. All these 1, 2, 3, 4, and 5. All these are the expectation. Expectation of students. And S was declared as a student class, right? So static type is students. On the other hand, these are outside the expectation for students. So they are not going to compile, okay? So think about right here. So these are the expectation of the child classes. So these are the expectation of the child classes. All right. What about the next two rows? I want to change the context object from S into RS versus NRS. Think about it for 1 minute. This will be the kind of exercise you will have to know how to do it very quickly in the written test and the exam. But of course, we are only learning now. So I want to make sure you understand what's the rationale behind. Of course, you're going to apply this in this example here. Practice that yourself. And also maybe when we introduce another running example that's more complicated, you also got to practice that. Right? OK. So now, if the context object here is RS dot, should this compile? RS? It will compile because the static type is resident students. Resident student inherits all the attributes and methods from the students. So whatever that's the expectation for its parents, it inherits that. So whatever that was, the expectation for its parents, we should have it. Similarly, for NRS, whatever the expectation is for its parents, we should have it as well. So this one tells us we inherit the expectation from our parents. Okay? So let's say this one here and this one here, right? So that means child classes inherits all the expectation of their parents. Another term I want to mention right away. What about resident students and non-resident students? So what we call them will be, if they're at the same level, we call them siblings. Okay? So these two are called sibling classes. Think about in reality sense. Do siblings inherit expectation from each other? Not quite, right? So it's not going to be the case, right? So what we got to think about is, how about the remaining part, right? If the context object is RS, can I say RS.PR? Of course, PR is right here, resident student, right? RS.set PR, premium rates, of course, it is right here. But can I say RS.discount rate? I cannot, because discount rate is in its sibling class expectation, which is not inherited at all. All right? So the way to understand it will be here and also here. And if you try to look at when the context object here, right, we talk about static type being right here, flipped. So that means these two will not compile, and also these two will compile, right? You want to look at this example more closely yourself. So I'll just do one more annotation for you. I'll put it here. So these two will be, so expectation of sibling not expected. So on the resident students class, you simply cannot call discount rate, for example, right? Any question about this? All right, now we got about 9 minutes. I can do one more exercise. I think that'll be a nice way to end the class today, okay? Let's now talk about this. Well, expectation that we just talked about is very important, okay? Again, we got this inheritance hierarchy. Let's now say this. I got student S, we got resident student RS. So we know that we got two static type. We got student here, and also we got resident student here. And then I also try to, okay, let's visualize that very quickly. So RS right here is a resident student's objects. And we know that for resident students, we actually have, of course, all the attributes inherited from the parent class, like a name, courses, etc. But specifically, for resident student, we got premium rates, right? So there will be a premium rate right here. And that one there is just going to be 1.25, all right? Just write it down. Okay, we got RS. Now, we got two variable assignment here. S is assigned RS. RS is assigned S. Question. Which one is going to compile? And which one is going to fail to compile? I can tell you one is going to compile and the other one is going to fail to compile. Tell me which one and tell me some reason. And then I will give you some quick reasoning, and that'll be it for today. And the idea has something to do with expectation. Anyone would like to give it a try?
Thinking the second one will compile.
RS is assigned to S?
Yeah, because like the resident student is a subclass of student, so it's like already implied that it's a student in a way, whereas the first one you can't go the other way.
So what you're saying is somehow you're thinking because RS is more like a specialized kind, so letting that be assigned to S might be okay. All right, guys, don't be offended. This is wrong. In some way, I'm glad you actually gave me the wrong answer, so it will make my reasoning more valuable. All right? At the exam or in the written test, you might be given something like this in order for you not to get confused. And you might forget about the actual rules. So it turns out this will compile, but this will not compile. Okay, first of all, that's the result. So to read, this will compile, but this will not. In order to really see why it will be the case, I want to give you some idea about reasoning about it so you can easily, quickly doing this reasoning again to sketch on your paper. So just quickly remind you. All right? So in your previous math course, or maybe, I don't know, in high school, maybe in the first year, have you heard about something called proof by contradiction? Right? Proof by contradiction goes like this. If I want to show that this code should not compile, why don't I assume that it's going to compile? If I assume that it's going to compile and then I will execute faithfully what it is suggesting, I'm going to run into contradiction, like a crash or exception. In that way, that tells me my initial assumption that it should compile should be wrong. So it should not compile. All right, so that's the way to go. Let's now do that very quickly. Okay, so this one here is not going to compile. Let's do that reasoning here. So number one, assume RS is assigned to S compiled. Assume that. How do we run into some contradiction? Since we assume that it compiles, let's say now execute. Execute the variable assignments. And what does it do? So we got actually RS over here. Rather than pointing to over here, it's now going to point to some objects S. S is students, right here, right? So that means it's going to now point to, okay, let me draw a little bit better. So now it's actually going to point to a student's object right here. And we know that student object should have name, courses, the name, courses, number of courses, etc. By the way, at the runtime, should student contain premium rates? It shouldn't, because you didn't declare that over here. So whatever that's going to appear in the student objects will just be the attributes we declare right here. Right? So no premium rates, first of all. Right? So number two, after this, RS is now going to point to a student object. Number three, remember expectation. Right? Number three, which is the most critical part. What will be the expectation on RS? Expectation of RS depends on the static type for RS, right? What's the static type for RS? Resident students. So this is the static type of RS. Is resident students, which includes resident students, as we said earlier, it should include premium rates. Premium rates. Since it's expected, so we should be able to call RS dot premium rates. But now, if we try to execute this at a runtime, what's going to happen? RS dot PR doesn't exist in this object. You're trying to access something that's not even there at the runtime, crash. All right? So this one over here is going to crash at runtime because students objects, okay, does not have premium rates. That means our initial assumption that it should compile is wrong. So it should not compile. All right. So guys, I think it's really good that we talk about this one at the end of today. So before Thursday, you really, really want to think about this page over here and also this page here. Give me 1 more minute, please. Okay, we're almost there. Okay, so number 4, RS equals S should not compile because we run into contradiction. All right, so before Thursday, you definitely want to think about this table here about expectation. And then go over this again to really convince yourself. You can also look at the slides. Why this will compile, but this will not compile. And go over the reasoning. It's going to help you a lot. We're going to dive much deeper into this. Something much more complicated is coming on Thursday. All right, I'll see you